Hello students, we're going to look at scale drawings and scale models today. Please take out your note sheet of paper and I want you to write down everything that I say. I'm going to give you some notes on it as well as work some of the problems on this sheet. First of all, if you will take a look, a scale drawing or model is used to represent an object that is too big or too small to be shown in its actual size. The dimensions of the object on a scale drawing or model are proportional to the dimensions on an object. So, some examples of scale drawing, scale models would be blueprints for a house, a model car, or even a photograph. The scale is the ratio of the size of the model to its actual size. So we are looking at model to actual. Write that down, please. And here it is, model to actual. But I wanted to write it like this so you have it in fraction form. This is how we'll look at it in fraction form. A scale can have the same units or it can have different units. And also you can use a scale to find a missing measure on the model or actual object. Simply set up and solve a proportion, which we have been doing a lot of lately. Okay, we are going to look at 3 problems together, and I want you to copy down all the steps as we look at these and do these. The first, a model of a car uses a scale of 2 1/4 inches equals 3 feet. If the model is 14 inches long, what is the actual length of the car? So again, we're looking at model to actual, and as you can see up here, we're in this case inches over feet. So we have 2 1/4 inches, which when I change that to an improper fraction, 4 times 2 is 8 plus 1 is 9. So I have 9/4 inches to 3 feet. And it tells me that the model is 14 inches long. So 14 is going to be my numerator. And then we're trying to find the actual length. Actual is in your denominator. So we just put that as x. So what we have, once we cross multiply, we have 9/4 x equals, and then 14 times 3, which is 42. So we have our fraction as a coefficient, 9/4 times x equals 42. To undo what's happening to x and to solve, we want to divide by 9/4. But remember, the shortcut would be to multiply both sides times the reciprocal, and I'm going to put that 42 over 1. So 4/9 times 9/4 x just leaves you with 1x, and then 42 times 4 is 168, and then 1 times 9 is 9. And on your calculator, if you will take your, in order to solve that, take your calculator, 168, remember this line stands for divided by, and divided by 9 equals, x equals 18.6 repeating feet. Or we could even round that to 18.7 feet to the nearest 10th. Okay? Let's turn our paper over, and we're going to look at number 8. It says a map of Texas uses a scale of 1.5 inches equals 40 miles. If Houston and Dallas are 8 7/16 inches apart, find the actual round trip distance between them. So once again, we're going to have model over actual. Copy that down as a reminder. And on that problem, if I take 1.5 inches, that would be the same as 3/2 of an inch. And we're doing inches to miles, and that would be over 40 miles. And then it says Houston and Dallas are 8 7/16 of an inch, which I'm going to make it easy and use a decimal. And on this 7/16, it would be 8 point. To find my decimal, I just do 7 divided by 16. So I would have 8.4375. And we are trying to find the actual mileage, so that will be over X. If you prefer to use the mixed number for 8 and 7/16, that's fine. To be honest with you, I don't really like having a fraction and a decimal in here. So instead of having 3/2, I'm going to change that to 1.5 inches. 3/2 would be the same thing as 1.5. So we're going to cross multiply. We get 1.5x equals, and then I'm going to multiply 40 times 8.4375, and I get 337 50/100ths. Divide both sides by 1.5, and we get x equals 225 miles. Again, be sure that you are writing down all the steps to solve. And finally, I'm going to do one more problem with you. We're going to find the scale. Just another reminder, we are going to put model over actual. To find the scale factor, it says write the ratio of the model length to the actual length, which is this right here. Step 2, simplify the ratio so the numerator is 1. In other words, divide the numerator and denominator by the numerator. I'm going to do it a little bit differently. I'm going to actually set up a proportion at this point, and I'll show you what I'm talking about. Two ways you could do it here, but I think setting up a proportion may be the easiest. So we're doing model over actual. Our model length, that's going to be the same as 32/5, 32 over 5 meters to 120 kilometers. So I have meters to kilometers equals what we want to know. We want 1 meter. We want to know how many kilometers does that equal. So keeping my proportion, keeping my units, meters to kilometers, meters to kilometers. And then I'm going to cross multiply. I get 120x. Nope, I'm sorry, 120 equals 32/5x. And remember, we can divide both sides by 32/5, or the shortcut would be to multiply by the reciprocal. So times 5 over 32. So on the right side, I'm just left with x here. 5 over 32 times 120. I'm going to multiply my 5 times 120, which gives me 600, and then I'm going to divide that by 32, because 32 times 1 is 32. Okay, and then at this point, I get 18.75 meters, and what that means is that 1 meter equals 18.75 kilometers. On the map. The way that she talks about doing it in step 2, and I'm going to show you that way. If you prefer to do that way, I think this way may make more sense. But she says simplify the ratio so that the numerator is 1. So let's look at this same problem on number 12. And I'm going to just go ahead and change it to decimals. So if we take 32 divided by 5, that equals 6.4 meters. And then, so what we're going to do, and again, we still have model over actual. So we would have 6.4 meters to 120 kilometers. But we want to know for 1 meter, how many actual kilometers does that equal in real life? So think, how do you get from 6.4 to 1? Well, you have to divide by 6.4, which means we would have to do the same thing to our denominator. So I'm going to take 120 divided by 6.4, and we get 18.75 meters. Again, that means 1 meter on the model equals 18.75 kilometers in real life. Use these examples to complete the rest of the problems on the front and the back. And if you get confused, I encourage you to listen to this again. Thank you.